You see the code back then. In fact, if I if I actually tell you, this is one of the case study of Amazon itself. Okay, when Amazon began, in the very early stages of it, okay, Amazon was merely what? It was simply a e-commerce website, right? E-commerce platform that we've had. Now, when Amazon began, this is the kind of architecture, the application code approach that they used to have, okay, where the entire code was written as a whole. The entire code was written as a whole. Okay, wherein the different functionalities, for example, they would be part of this single entire code. Okay, so let's just say there is this A functionality. Let's just say it is taking care of the searching within Amazon e-commerce website. Then let's just say another one, the billing one, another one, the shipping one, right? So different functionalities, right? Or different individual services. Okay, they were basically compiled together to form a single application core. Okay, a huge application core. Now, here are certain things I would like to discuss. Now, this approach, where the application core is written as a whole. This we basically refer to this way of programming. This way of programming. This is something we used to refer to it as, or we used to call this to be as, this is tight coupling or tightly coupled architecture. Okay, wherein you see individual services, individual components of your application, they are integrated together as a whole application. They had tight coupling. Now, what do I mean by tight coupling? Let me just give you an idea. So because they are so interrelated, okay, this is in fact what is the other way of looking at tight coupling is we call it they were interdependent. So for example, if you just have a look at it, interdependent is what? Okay, this is where we have one component dependent on the other, the third on the second, and so on. For example, if I just want to give you a real-time example, let's just assume that there is a single database around which your application is built. Okay, so let's just say from the Amazon use case itself. Okay, we have a single relational database for the entire e-commerce website, and all the other functionalities are built around it to match or to make sure that it is compatible with that. So this way where you have interdependent architecture, okay, one component is dependent on other, okay, this is what we refer to it as tightly coupled architecture, okay, or interdependent architecture. Now, what are the benefits? What are the disadvantages of it? Why I would not want interdependent architecture? Can you identify this, team? Let me just give you a minute or so, okay? Just try to put it into chat box. What do you think? Why would I not go for such interdependent or tightly coupled architecture? What are the drawbacks of it? Can you identify? Yes. Yes, team. What do you think? Why would I go? Or what could be some of the problems, let's just say, that are associated with your tightly coupled architecture? As you can see in this case, interdependent architecture. Isn't it? So exactly. So you see, some of them could be like one. I'll just mention. If I have such tightly coupled architecture, what will happen is in this case, the individual components, you see the A and the B and the C that I've written, they will be so interdependent that it will be difficult for me to scale my application individually. For example, let's just say I just have to scale my component A. Now, that's not so possible because I'll have to see for the effect of A on the other components. Okay, if I just want to draw it again, just to give you a clearer idea, it will look something like this. Okay, just think of it like this. Just imagine it this way. Okay, this is the A component. This is the B component. This is C. This is D. Okay, so if I just want to change something about this A component, how can I go or how can I do it without looking at B and C, which are interconnected with A? And when I consider B and C, how can I miss out on D? So basically, the idea here is that team, the idea here is that a single change, a minor single change that we might think, is very, very little and very minor, still it can impact it. It had the potential to impact the entire application as a whole. So scaling was difficult. Second, refactoring was difficult. Why? Because you see, let's just say if I go and modify something about component B, again the same thing, I cannot consider that component individually anymore. I'll have to also consider the effect of that change on the corresponding and neighboring components like A, the C, the D. So again, the refactoring is problematic. Third, you see, the failures. For example, let's just assume that this B component fails. Now, because B is dependent on A and D will as well be at the risk of getting impacted. And if A and D are getting impacted, for sure, because C is dependent on A and D and B, all of them, and because A and D and B got failed, for sure, your C as well will not be spared. So team, the idea here is that the failures that used to happen earlier, they were a lot more catastrophic. They would, with literally a simple and a minor change or a minor failure, is it that can affect or that can put your entire application at the edge of crashing down. Okay. And what used to happen, I'll tell you. Okay, now just pay your attention because this is where it is going to be really, really interesting. What used to happen? Okay, so let's just say this code you have prepared it. No, how would you prepare it? So the way we used to prepare it is, we had to. Because it is a combination of many components, no, many individual services, A, B, C, D, E, F, whatever. So what used to happen is our team of developers, they would sit together. They used to sit together like this. They used to sit together like this. Okay, this we refer to it as a dev team. Now, because again, just try to understand the reason behind that too. Because you see, these components, even though I am an expert in the A component of the application, I cannot sit alone and prepare my code without having the discussion with B and the C component experts. Okay, I'm just telling you from a simplicity point of view. Okay, might not be individual components, but in reality, it could be something like, a particular domain or a particular area, whatever. I'm just telling you for the sake of example, but just try to understand, team, that in order to code the entire application, there was no other way than sitting together as a team of developers to prepare that code. And then what used to happen is that this code would then be thrown to the other team, like we have known, okay, the ops team, right? The ops team. Okay, the ops team again will have some members that are part of it. And again, this back and forth used to happen for the very reason that, as I've told you already, this was kind of a virtual wall that got set up between the two. And by the way, team, this traditional architecture, I'm not sure how many of you have heard it, but this traditional architecture, we refer to it as monolithic architecture. Okay, now, which one? Yes, Imanshu, which exactly? Can you please tell me? So you're talking about Amazon website, is it? Imanshu, I'm not able to hear you if you're saying something. Let me just check, okay? If no, that's what you know. That's it. I mean, I was talking about the live example itself. So, for example, I mean, Amazon website. Just think about the Amazon website itself right now that we are having. In that Amazon website, right now we don't use this method anymore. Okay, because this is kind of the old way Amazon used to use it. We don't use it. They use this particular method anymore because of the very problems that I've told you. Is that the scaling, the refactoring, the failures. Okay, there are many more things I'm going to add in a minute. Okay, so these are many things that used to happen wherein, for example, let's just say in the Amazon website, as I told you, let's just say what used to happen is that there used to be a single database, a central database around which the entire application used to be built. And even, I mean, many components, they were used to be dependent on each other for that very sake. Isn't it? So the idea is that we want to decouple that functionality. Okay. So, like I was saying, team, that in those times we used to have such a day when the ops team, when the developers used to sit together and prepare this code for us. That code was being put across to the ops team. Ops team again would look out for the implementability of, deployability of that code, making sure that that code can go into production in a stable and a reliable way. Right, but in case it doesn't go well, it will again inform the same thing back to the developers. Developers will again fix it, and so on and so forth. So the idea is that this is the kind of architecture that used to happen, and because of this day when the ops or the, I mean, overall hierarchy or the structure, there are few more disadvantages that you can see. For example, the fourth one is long development cycles. Now, what do you mean by that? So try to understand, team. I mean, as I've told you, that even a small fixture or even a small upgrade on a particular component, we could not do it individually back then. Okay, it was literally a task of an entire upgrade of your application, because that minor upgrade, you don't know, might affect which components in what way. Right. So exactly for that regard, we used to have long development cycles. Okay, let's just say 6 months, 8 months, 7 months. The developers used to, or basically the team used to, or rather, in the monolithic architecture, we used to have that long duration. Now, as I've told you, and again, one more thing I forgot. Okay, so again, there is one more disadvantage, which is really important. Is in regard to accountability, or you can say responsibility. Now, what do I mean by that? So you see, team, let's just say something goes wrong with this B component. Now, who can you blame for the core of it? Because you are sitting through entire as a team, right? There is no accountability or responsibility that you can put much when you are working in a structure like this, where you are working as a team of 20, 30 developers together. So you cannot blame. And it is not about blame, but it is also about accountability and responsibility. That you no longer you are no longer, in fact, in this case, accountable in any sense. Now, looking at this, as you can see, this was a big problem back then. Company like Amazon was as well struggling with it. And then they came up with an entirely newer approach. In fact, the word back then adopted an entirely new approach, and we call it the approach, the microservices. Now, this is something, team, I have discussed with you earlier as well over here. Okay, this is the kind of structure that we have in the microservices, but okay, we never discussed it in detail. So, what happens in microservices? So the microservices, we tackle the most important issue in the monolithic architecture. And what is that? The biggest of the biggest challenge or the problem that we have here is the tight coupling. Okay, every component you can see, it's dependent on any other component for that matter. Now, you see, what microservices did then? I mean, what exactly is the change that we saw in this particular approach? So what we did here, see, we created the tight coupling was the problem, you know. So what we did here is that now we gave our individual services the freedom from the tight coupling. Okay, so we no longer have a tightly coupled architecture like before, like monolithic. Rather, in the microservices environment, you have individual micro. This is what referred to as microservice. A is a microservice. B is a microservice. So is C and D. So again, the idea is that the only problem that was causing all of these issues, we are trying to tackle it here in the form, for example, yes, again, when I say they are independent, they were earlier interdependent. Now I'm saying that we have brought in the loose coupling. Why am I not saying fully independent? Because still, you see, these all microservices, they're part of a big application as a whole, right? So there is an interaction that's required across those individual microservices, but not to an extent that would hamper the other components or rather put it at the risk of failure. Okay, so not as much, but still, we made sure that they will be talking to each other through the APIs, okay, to a minimalistic level, in fact, not to an extent that one can affect someone else's or some other microservices in an adverse way. Now, this team, you see, brought revolution in the field of software development lifecycle, because this was an entirely different point of view that we never thought of before. So some of the challenges, I'll tell you how this is tackled. The team earlier, you see, we used to have a team of developers who would be working on the entire application code, and then they will pass it to the ops team and all. Because again, you see, the code that was supposed to be written was written as a single code as a whole. Next, what's so different in the microservices then? In the microservices, instead of attaching the entire dev team for the entire development project, here is something that we did. Okay, so instead of having an entire team of developers, what we did is we just assigned individual developer to individual microservice. Okay, now, what else? Not only that, we did not even stop there, but as well, we went further and we associated an ops person along with. Okay, a team this way, instead of having a big team of dev and the ops, now it was possible for us to have smaller teams. Individually, you can see like this. This is team A, for example. Let's just say this is team B. In fact, if you read out the documentation, no, our Jeff Bezos, he in fact called these teams as two pizza teams. Then we had a third team there. Team 3. We have the fourth team there. But team, you see, this is in fact, even I had discussed in the last session as well. If you come here, okay, this is exactly what I've discussed, right? That you no longer have an entire set of people working as a team. Rather, you'll have teams that are made up of different talents, different skill sets altogether. Okay, for example, again, for every microservice, I will have a developer, an expert developer, an expert ops person. A combination of them would make it lot more transparent, or not in lot transparent, and even it will make it a lot more accountable. I'll tell you how. Now, if I want to put the benefits of it, in fact, you can see the very benefits, which are exactly the ones that we were struggling with during our monolithic architectures. For example, now, whether the scaling is possible, yes. How? So, because I have now individual microservices, we are no longer working on entire application as a whole. You see, that makes scaling individually possible because they are no longer tightly coupled, So this scaling is truly possible with that. Second, refactoring. Well, let's just say I have something. Okay, just a second. Okay, so like I was saying, that the refactoring is now possible. How? Just try to understand. You see, earlier the refactoring was why it was not possible because if I went to refactor a particular component, that would come in the way of, or that would affect the other components nearby. Right. So that's exactly what is possible now because now the components have got their own independence. Okay, so refactoring is as well possible. Third, failures. Now let's just say for some reason this component does fail. Okay, but still you will see that unless it is a major component or a kind of a major thing happening there, it will hardly or rarely affect the other components in the backend. Yes, it will disrupt the application in case that API is so important, but still I'm saying that it will not be as fatal, as catastrophic as it was in the case of monolithic. Long development lifecycle. It is no longer long anyhow because you see, in this case now in the microservices, each component, each microservice will have its own software development lifecycle. Now, this is one of the biggest statement I'm doing to you. And you have to keep in mind is while in the monolithic, you have a single life cycle for this entire code from scratch to the end. But in the microservices, the biggest of the benefit is that you get individual life cycle for individual components. Now, what does that do is you'll have lesser or you'll have very frequent deployments. Okay, because you no longer have to wait for the other components to get upgraded. You'll upgrade your application directly with that particular component without thinking much over the other components. So long development cycles have cut down. In fact, we say in the DevOps world or in this overall microservices world that we have earlier, while or when we used to have one deployment per 3 months or in 4 months, now we have 5 deployments a day. This kind of flexibility and this kind of uh, evolution we have observed in the microservices environment. Okay, and finally, again, you can see one of the biggest thing that microservices is said to provide is that it comes with accountability and ownership. Now, team, try to understand what I'm saying. Accountability, as in you will be responsible for that particular component. For example, anything going wrong for this component A will be the responsibility of team A there. Okay, and the people involved in it. For example, if it has something to do with the coding aspect, the developer that belongs to team A would be something or someone to talk to. On the other hand, let's just say something goes really well, you have performed or you have exceptionally done well in terms of choosing the appropriate component and the size and the services and the cost and all, you will be the one who will be praised for, right? So you see, it's a two-way kind of a tool, right? Accountability on the one end, which is also equivalent to responsibility. And finally, you have ownership that you get. Okay, individual team. For example, team A will own this component A. Team B will own this component B. Team C or team 3, it will own this component C, and so on and so forth. Why I discussed this is because this is exactly what is the foundation of DevOps, as we discussed the last time around as well. Is in the DevOps, one of the very foundational principle is microservices. Okay, and that's exactly where it came from. It is expected that you are utilizing or you are having microservices environment in the DevOps project. Now, let's just this is one important thing, team. Let's just now outline the DevOps pipeline once and for all, because this is the pipeline that will be coming across very often in the time to come. In fact, it is exactly what we have discussed for the waterfall model and for even your agile model. But let's just see it more from a DevOps perspective. How does this overall setup looks like? Okay. Now, team, just pay attention. Okay, this is one diagram that will be coming across a lot. Let's just say this is your developer. Developer will prepare the code and will push it into the corresponding code repository. Okay, so the code is the first phase. Now, team, can you tell me what are the very popular code repositories that are out there? The ones where we can store our code in a reliable way. Any that you can remember? Yes, exactly. GitHub. Okay, so GitHub is very popular one, you know? Yes. GitHub is very popular one. We can have GitHub. We can have Bitbucket. Okay, and so on. Now, team. Yes, exactly. Now we'll take it further. As I've told you, the next logical step is build and test. Team, I want your full attention. Okay, I'm going to discuss a very important concept here. Is over here we have a test phase. So just observe this. Okay, just observe this. What happens? So your developer using its own ID, it will be pushing the code into the code repository like GitHub and Bitbucket, and this will drive or this will trigger the build and the test. In fact, this build and the test team we can carry out with the tools like code build if you're in the AWS environment, or you can use Jenkins for that very sake. Right? So we can carry out the build and the test. Now, until now, what I had shown you is every time we came here, I've shown you that it goes for the provision and the deploy and monitor, right? As you can see here. But that's not reality, right? In actual reality, what may happen is that my test might fail. The test might fail some of the conditions and some of the constraints that was put there. So what can be done? Okay. So in case the test or the build fails, this is immediately notified to the corresponding developer. Now, what will happen in this case? Again, the developer will set through, again, fix those issues. Again, it will pass in that. Again, the code will be built and tested. Again, in case there is an error, again, that will be conveyed back by the test phase back to your dev phase. Now, team, this loop, remember, this loop that I've shown here, okay? This loop, let me just use some different color paint. This loop is what we refer to in DevOps word as continuous integration. Okay, CI. Okay, now continuous integration, remember, this is a process in the DevOps where your developer is continuously pushing the code into the code repository. And from where the code phase or the code step will trigger the build and the test. In case there are some discrepancies or issues, that will be notified back to the developer. And this process will go unless and until you get the best quality code at the end of it. Okay, so that's exactly what, and by the way, team, that's exactly is what is the aim of this process. Okay, CI is you give out the best quality code. Now, let's just say that the code is out. Now, if the code does follow all the restrictions and the requirements and the compliance, then it will go for the further stages. Okay, then it might be provision. Then it might be deploy. And finally, it could be monitoring. Okay, so the idea is that when the continuous integration barrier is crossed, okay, then your code can go into provision, the deployment, the maintenance, and the monitoring, and all of it. This process team, remember, this process, this entire end-to-end process, from the developer to your monitoring and all, this is referred to in the DevOps word as continuous. Let me draw it down. continuous deployment. Okay, this process, when it is end-to-end automated, then we refer to it as continuous deployment. In short, we call it CD. Now, team, I am sure you must have understood the real meaning of CI/CD. Okay, CI, continuous integration, CD, continuous deployment. But there's a catch here. This D, it has some different meanings as well. Okay, so yes, one of them is continuous deployment. Okay, but there's one more, I'll tell you. Okay, for example, if I just take this up, okay, it is very similar to the continuous deployment. But what happens over here is before your code is going to go into final production, the companies, they generally carry out some manual check. Okay, or we also refer to it as manual invocation. Okay, why? Because I may want to verify whether that particular code that is going to go into production, whether it is worth it, whether that's correct. Okay, so this, when happens, this is basically referred to team as continuous delivery. Okay, so team, remember the difference. This is a very, very important difference that if you're going for any interview, you might be asked. Okay, if you're applying for a DevOps particular course. Okay, so or a particular role, right? So continuous delivery, again, it also stands for CD. Okay, so when I say CD, sorry, when I say CI/CD, or when we will say CI/CD from today on, just remember that you have to be a bit careful when using that word D. Okay, it can be either continuous delivery, can be either continuous deployment, isn't it? And with that, it can be either continuous deployment is fully automated. Continuous delivery does have manual intervention. Again, team, the real goal is to make it fully automated as much as that you will never require the data, or you will never require, or you'll never have rather the manual intervention that can affect or impact our application adversely. The human errors in case. Also, so full automation is always the great thing to have, but at times it is inevitable to have some manual intervention as well, and that comes in the form of continuous delivery. Okay. Now, talking about some of the different tools that we can use, for example, provisioning. Okay, we can use a tool like Terraform. Okay, we can use a tool like CloudFormation. Okay, on the deploy, we can carry out with the code deploy, maybe with the code pipeline. Isn't it? So, team, you see, Ansible is more for the configuration management. Okay, we'll see that as well later on. Okay, so team, you see Jenkins, Terraform, CloudFormation, you see code deploy as we discussed, GitHub, right? So that's some of the things that we'll be exploring. Okay, we'll be exploring as we will move further with our discussion and as we'll be going forward. Okay, but overall team, just remember this is the DevOps life cycle as we call it. Okay, DevOps is nothing but bringing the dev and the ops together. Okay, making them work together. And we have seen exactly how. Okay, so if you remember, we've seen how the traditional architectures like Monolithic, they used to work. And now how the advanced and the lot more flexible microservices architecture we do have, where we'll have individual teams that will be taking care of individual components. Components, we refer to them as microservices. Okay, so let's just outline, team. Finally, what are some of the characteristics of DevOps, or I would say principles? Principles of DevOps. Okay, principles as in these are some of the things that are expected when you are in a DevOps environment. One of them, as I've told you, is microservices. It's kind of expected, or rather assume, that you are using microservices in there. Second, we have infrastructure as a code. Now, team, remember, DevOps believes in fact, I'll just write that down as a next point. It believes fully in automation. Now, what do I mean by that? It's not just about the automation of the process, but overall entire automation. For example, automation of creating the resources and your uh, environment as well. Okay, you can use infrastructure as a code for that. Okay, again, one more thing. Communication and collaboration. Okay, so team, you see, it's making sure. Now we make sure that as a part of a DevOps environment, okay, these are some of the minimum things, okay, that we are expected to have. For example, microservices environment, we do have infrastructure as a code, we do have RAC, automation, we do have, right? And communication, collaboration, we want to make sure that we align or reorg our organization to make sure that our dev and the ops work together. And it's not just about one dev and one ops, but I'm talking about as such multiple in order to run a DevOps project. Okay, so team, from here on, we'll start to explore. In fact, we call the DevOps, is it in the definition as well? It's a combination of dev and ops to the cultural philosophies, tools, and services. So that's exactly what we're going to do. Is we are going to explore the DevOps with its real might and see how the different services can be used in the DevOps environment. Okay, but as you can guess, this is going to be something that we'll be exploring in the session to come. Okay, in fact, the overall general DevOps introduction is all done now, team. We'll be moving for the specific modules. Okay, so just give me a second. Let me just quickly upload the whiteboard as you might have needed. Wait a bit. Today is 18th, so let me just create a notebook with that. And if you, as you want it, I'll also share it in the PDF format too. And where's that gone? Okay, got it. Okay, now I'm uploading first of all the OneNote. Okay, and finally, I'll also upload, and I'll share the link of it, by the way. I'll share it. Team, have a look at it. This is the link that you can use for downloading the whiteboard in the OneNote format. And let me just export that out in the PDF format too. Okay, just in a minute. I'll be sharing the whiteboard in the PDF as well. Okay. Take some time for it to set up. Eighteenth. Okay, so yeah, done uploading. Now so let me share. Okay, this is the PDF version. Just have a look at the link in the chat box. Okay, team. So both the links I've shared with you. Okay, and yeah, from tomorrow on, we'll be starting to explore the different components of this DevOps lifecycle. We have called it as a CI/CD pipeline. Okay, we've seen what is CI, what is CD. Okay, what is the importance of monolithic microservices, how they are different and all. Okay, but tomorrow on, we'll be starting with some real services as a part of it. Okay, team. So that's it for me from my end right now. Okay, and yeah, I'll see you tomorrow again with some new learning and some new concepts, and we'll take our discussion from there on. Okay, so that's it, team. Thank you very much, and yeah, I'll see you tomorrow. Thank you, everyone. Have a great day today. Sorry, tomorrow, and a good night today. Okay, thank you, team. Bye.